Hello, this video is for IXL Activity A1.F.5. It is titled Surface Area, and the 3-character code for this activity is Victor Golf Tango. So, surface area. Well, here we have a cube we're going to start off with. And whenever we talk about surface area, we are talking about the amount of area on all the external sides of these particular objects. In this case, we have a cube. Be a polyhedron, to be exact, 3-dimensional object. But at any rate, so we need to determine the surface area of the cube. Well, cube has, 6 sides? We can see 3 of them here. 1, 2, 3. And then we've also got the bottom side. And we have this back side over here we can't see. And then we have the other back side over there that we can't see as well. So we know that there are 6 sides. And all of them are going to be the same, because notice that the length, width, and height are all the same. So if the length here is 7, and over here we see the height here is 7, then we also know that this is 7. We know that this side has a length of 7. All of these sides have a length of 7. And that means that each face of the cube, by face I mean the side, each side of the cube is a perfect square. And we know that the area formula for the area of a square is the side length squared. So with that said, we know that the panel over here, this side over here, is going to be 7 squared. Up here, it's also going to be 7 squared. And here it's going to be 7 squared. And on the back side, each of the back sides, and also on the bottom is going to be 7 squared as well. So we have 6 sides that are going to be 7 squared. So in this case, I'll say SA for surface area is going to equal the side length squared and then multiply it times 6. Well, I would prefer to write this as surface area equals 6 times the side length squared, in which the exponent 2 only applies to the side length. So let's go ahead and do that. We'll plug in our values here. Surface area equals 6 times the side length is 7, and we want to square that. So we're going to have surface area equals 6 times the value of 7 squared, which is going to be 49. And now for surface area, let's go ahead and bump my mic there, grab my calculator, because I am not going to do 6 times 49. I could probably actually do that mentally. 300, 294, I believe. 6 times 49 is indeed 294. So 294 is the surface area. Oh, not S. There we go. 294. So formula for a cube is going to be surface area is equal to 6 times the side length squared. Looking at the next one, we have a rectangular prism, and we have a length of 3 and a width of 9 and a height of 2. Well, we have 6 panels still. We still have 6 sides to a rectangular prism. We have this front here is here, and then the back side is the second side. We have a third side here, and then that back side there would be the fourth side. And then we have this fifth side here, and then underneath would be the 6th side. So we do have 6 sides of a rectangular prism. And we know that this front side here and the back side are the same length. So let's kind of put this together. Let's come up with a formula for this. Surface area is going to equal, and we have this panel up here that's 3, and if this is 2 back here, then we know that this is 2. So this is going to be a 3 by 2. So in this case, and how do we want to do this? Let's do a formula first. Let's do a formula, and we'll come up with the actual plug it in the values. So let's go ahead and do a length, a width, and a height. So we have a length, width, and a height. So our length is going to be 3, and our width is going to be 9, and our height is going to be 2. So for the front side here, we are going to have the length times the height. So we're going to have length times height, and we want to go ahead and have that times 2, right? So we have 2 there. So that takes care of the front panel and this back panel back here, right? Now let's go ahead and do this panel over here, the 9x2, and its back panel over there. And we're going to add each of these together. So it's the front panel, the back panel here, and that is 2 times the length times the height. On the second one here, we're going to have a 9x2, so that's going to be our width times our height, 2 times our width times height, and then add to that the top panel, which is what, 9 here and 3 here. So that's 9 and 3, that's our length and our width. So that's 2 times the length times the width. So it looks a little messed up there, I suppose, but we'll go with that, all right? And that would give us our surface area because we have 2 panels here, 2 here, and 2 here for a total of 6 of them altogether. So let's go with our surface area is going to equal 2 times the length is 3 times the height, which is 2. And we're going to add to that 2 times the width, which is 9. And multiply that times the height, which is 2. And then add to that 2 times the length is 3. And times the width is 9, times 9, and we're all set up to go. We covered everything here. So surface area will equal, in this case, let's do all of our multiplication first, and then our addition to deal with the orders of operation. So 2 times 2 is 4, times 3 is 12. We're going to add that to 2 times 2 is 4, times 9 is what, 36. And then 2 times 3 is 6. 6 times 9 is 54. Now we've done all of our multiplication. Now we can go ahead and do our addition. And yeah, I'm going to be a cheater and put all this in the calculator. 12 plus 36 plus 54 is going to give us a total of 102. So our surface area is 102 square inches. Next, we have a triangular prism here, and we need 2 triangles, and we're going to need 3 panels also. And we see that on one side here we have 20, and on the other one here's 20. That means this back side over here is 20 by 20, but the bottom is 24 by 20. So let's go ahead and piece this together. First, we need the surface area of the 2 triangles. So let's go ahead and deal with the surface area of the 2 triangles. And we're going to put this in parentheses to work with that. So we know that the area of a triangle is 1/2 times the base times the height. So let's go ahead, and I'm going to write 1/2 is 0.5 for this. So 0.5 times the base times the height. And but we have 2 triangles, right? So let's go ahead and put enough room in here. Let's move that over so that we can put a 2 in, because we're going to want to double that. Next, we want to go ahead and add to that this panel here, and it all depends upon the dimensions. If this were, it's kind of difficult to come up with a formula for a triangular prism because we don't always know that the end is going to be an isosceles triangle. We don't know if it's going to be a equilateral triangle, or we don't know if it's going to be scalene. It could be any of the 3. So on this one here, we'll have to consider how we want to do this. So as we look at it, let's go ahead and consider this panel here and this panel on the back side here. We'll consider those 2 panels. Notice they're both the same size because we have 20 here, and maybe I should switch to a different color. That red's not showing up very well. I have 20 here and I have 20 here. So this panel right here is going to be 20 by 20. And that back panel over there is also going to be 20 by 20. So it's really hard to kind of build a formula for that because I would have to have a separate formula for the 3 different types of triangles. So let's go ahead and just work this particular one, not really with a formula, but just kind of put it all together. So let's go with our surface area is going to equal our 2 triangles, and let's put in that 0.5. And then we're going to multiply that times the base. The base right here is 24. And we're going to multiply that times the height, which we see here is 16. And then we have to add to it those two panels. There are two of them, right? And each panel is 20 by 20. So we're going to do 20 squared. We'll just do 20 squared instead of 20 by times 20. Same difference. And then we'll add to that this other panel down here. Now the panel on the down, whenever I say down here, I'm talking about the bottom one down here. We see that that panel, and again, I'll change colors here. We see that panel is going to be 24 on one side and 20 on the other. So over here, we're just going to have to write that up as 20 times 24. And I'm going to change back to red. There we go. Go back 20 times 24. Now we'll go ahead from there, do all of our math, and we'll come up with the surface area for this. So let's first go ahead and do the 0.5 times 24 times 16. So 0.5 times 24 times 16 is going to give me a product of 192. 192. And I'm going to add that to 2 times 20 squared. So let's go ahead and take 20 and square it, and then we will double that, and that's going to give us 800. That was for those two panels that are 20 by 20. Now we're going to go ahead and add to it the 20 times 24, and that's a product of 480. Next, I want to go ahead and deal with this 2 times 192. So do 192, multiply that times 2, and I'm going to get a total of 384. Let's go ahead and bring down our 800 and bring down our 480. Now we're going to add all of these values up. 384, add to that 800, and add to that 480. 480. That's going to give me a total of 1,664. 1664. 1,664 square centimeters for the surface area of this triangular prism. Again, kind of hard to build a formula for it because whether it was an equilateral triangle, an isosceles triangle, or a scalene triangle would make a difference in how the formula worked out. On this one here, what is the surface area of this cylinder? Well, we need to use pi equals 3.14 and round our answer to the nearest hundredth. All right, so surface area for a cylinder. Well, let's think of the sides. Well, first we have a top and a bottom, right? So we have the top here, we have the bottom underneath. So we have two circles, correct? So surface area of a circle, or area, just go with area of a circle, is pi r squared, right? And so let's go ahead and do that. So for surface area, let's deal with the circle part first. We'll go ahead and put that in parentheses. Oh, wait a second. There's two of them, aren't there? So let's go ahead and put a 2 in front of that. We're going to want to double that. And now, pi, we're going to use 3.14. And I guess I could have built a formula first. Let's go ahead and build a formula first, and then we'll work from the formula. So I have pi r squared. So there's my top and my bottom. I have them both because I already have a 2 there, correct? And throw that back on there. I'm going to add to that around the outside here. Well, this one's kind of tricky because if you think about it, if we were to unwrap this, let's think of it as a label on a can, right? If you went ahead and just cut this right here and then peeled that label off, what would you get? Well, you would get a big rectangle, right? You'd have this rectangle, and if you pulled the label off of the can there, I'm trying to get my line straight as best I can, but you would have this rectangle here. And this top edge, well, what is that? That is actually the circumference of the can here, right? That's the distance around the outside. So we would have to know the formula for circumference. Well, circumference of a circle is equal to 2 pi r. So up here is going to be 2 pi r. And then over here we have the height, which is 5 in this case. So we want to add to that the quantity of, let's put it in parentheses so we kind of keep it separate. 2 pi r is going to be our circumference, and we're going to multiply that times the height. I could have left the parentheses off of there. Either way, don't really. Or if you wanted to get this even more, you could say surface area equals 2 times quantity of pi r squared. And then we would add to it, which order would I want to put those in? 2r pi, 2 pi r h. Let's go with 2. Let's just do 2 pi r h. We'll call it that. It'll all work out. So let's plug in our values. So surface area equals 2 times the quantity of, well, pi, they want us to use 3.14, so we'll use 3.14. And we're going to multiply that times, we really don't need the parentheses because this is all multiplication through here, right? I can multiply all this inside and then do that. But instead, let's go ahead and work with this. Our radius here that we see is 6. If I take the circumference off of there, we might be able to see that a little better. So 6 is our radius, and it should be squared. Add that to 2 times 3.14. Multiply that times our radius, which is 6. And multiply that times the height, which is 5. Getting that 5 from right here. So with that said, we're going to have surface area is equal to, let's do 6 squared is 36. Multiply that times 2. And then multiply all that times 3.14. Times the answer. There we go. Is going to give me 226.08. Now let's do 2 times 3.1. And boy, I'm really out of it today. That's supposed to be 3.14. We'll go ahead and change that. I put 13 for some reason. And I did it again. So 3.14. There we go. So 2 times 3.14. Multiply that times 6. And multiply that times 5. Look at my calculator. Yep, got all that right. That's going to be 188.4. Now I just need the total of what would be the surface area of the top and the bottom, and then the surface area of the sides is what I'm doing there. So I have 188.4. Going to add to that 226.08, and that's going to give me a total of 414.48. And it stops at the hundreds, which is nice because they want us to round to the hundreds. So 414.48. Okay. And now a cone. Cone's kind of an interesting one. I actually had to go look this up. It's been a long time since I've done the surface area of a cone. The surface area of a cone, it's actually not too terrible of a formula. It is pi times r times the quantity of, I believe it's S plus r. Yep, S plus r. This is the formula for the surface area of a cone. So where, in this case, we know what pi is. R is going to be the radius, which is going to be the distance from here to here, the circle part of it. And then S is for slant. And whenever we're talking about slant, we're talking about this measurement right here, from the apex of the cone down to the bottom of the cone, which would be the circumference of the circular base. So with that said, let's go ahead and do surface area equals, and again, using 3.14 for pi, 3.14, and then we want to multiply that times the radius, and this is 56.8, and that's the diameter, so I need half of 56.8, so I'll divide that by 2 and get 28. So our radius is going to be equal to 28.4. So let's go ahead and put that in, 28.4. And then we're going to multiply that times the quantity of the slant, which is 59. And added to the radius, yep, of 28.4, 28.4. So I'm going to do a couple things here in this step. Let's do the 3.14 times 28.4. 3.14, multiply that by 28.4, and I'm going to get a product of 89.176. And I'm going to multiply that times the sum of 59 plus 28.4. So 59 plus 28.4 is a sum of 87.4. 87.4. Now I need to multiply those two, and that's going to give me the total surface area. So 87.4, multiply that times 89.176, and that will give me a product of 7,793.9824. And we want to round to the nearest hundredth. So here's the hundredths place. Looking to the right, it's a 2, so we're going to let that 8 stay as an 8. And we're going to end up with 7,793.98 square meters for the surface area of this cone. Again, that formula is going to be pi times r times the quantity of S plus r. Keep that one handy for this activity. All right, now they get to where they give you the surface area and you have to solve for the unknown variable. So how that works is we're going to use those formulas that we developed, and instead of plugging in everything on one side of the equation to get the surface area, instead we're going to substitute in the surface area on one side of the equation, put the formula on the other with the information we know, and then solve for the unknown variable. So in this case, remember that the surface area of a cube is equal to 6s squared, right? Side length squared times 6, because there's 6 sides. So let's go ahead and do that. So we have 28,814.94, and this equals 6. I'm thinking I'm getting confused because I'm looking over at D. I'm wanting to write S, and it's got a D there. So let's do 6, and we're trying to solve for D. D is the side length, right, which is S, and we're going to square that. So now, first we need to divide by 6 because we want to get rid of that 6, so we just end up with D squared. We're working toward isolating that variable. So what I do to one side, I'm going to do to the other. Those 6's will cancel each other, leave me with D squared on the right. And then 28,814.94 divided by 6 equals 4,802.49. Now, to get rid of a square off of a variable like D squared, and I just want it to be D, what we do is we take the square root of that. And whenever we do that, we end up with just D here. And what we do to one side, just like up here where we divided both sides by the same number, we're going to go ahead and do the same thing to each side, and we're going to take the square root of 4,802.49. Well, I've already got that in my calculator here, so I'm just going to hit my shift key in the square root button, and that's going to give me, if you're not familiar with the TI-84, see, that gives me a neat little box to go ahead and just type in. Actually, I don't have to type it in. I'm just going to hit shift and answer, and it's going to plug in that 4,802.49. So hit shift, answer button, plugs that in, and it is 69.3 is the side length. So 69, and again, dyslexia strikes again, 69.3 is indeed the side length. Just use the formula, solve for the variable. We're going to do some more of that. So here we have the surface area of a rectangular prism, and it is 824 square millimeters. What's the value of S? So let's go ahead and think about what did we come up with for that. We said that first let's go ahead and go with length, width, and height. Our length we're going to say is equal to S. Our width is going to be 14, and our height is going to be 5. And the formula that we had was 2 times, in this case, we're going to go with length times height. Length times height. That would take care of this panel and this one back here. And we're going to add to that 2 times the quantity of the front and the back here. So the front would be, what, 14 by 5. And that is actually our width and our height. Width and height. And add to that 2 times the top and the bottom, right? And this is going to be our length and our width. Our length and our width. So let's now just plug in some numbers and see what we got. It is the length that we're missing, so we're going to put in this surface area of 824. Set that equal to 2 times the length, which in this case is S. We're solving for S. Multiply that times the height, which we have as 5. And then we're going to add that to 2 times the width, which is 14, times the height, which is 5. And then we're going to add that to the product of 2 times the length, which is S, and the width, which is 14. And let's see what we get. So I have 824, and I have 2 times S times 5. Well, I can do the 2 times 5 and get 10, and that's going to be 10S. The S is still there. I'm going to add that to 2 times 5 is 10, times 14 is going to be 140. So I end up with a constant there, no variable. And then over here I have 2 times 14, which is 28, and I still have the S there as well. Now I need to go ahead and combine some like terms. So 824 equals, I have 10 S's and 28 S's. Let's add those together for 38S and bring down my 140. Now let's subtract 140 from each side. And whenever I do that, that's 824 minus 140. And that's going to give me a difference of 684. 684. And now I want to bring down my 38S. And now from there, let's divide both sides by 38. That's going to leave me with just an S on the right. And 684 divided by 38 is going to equal 18. So S equals 18. So let's think about it. Does it make sense whenever we look at the picture? Does this look like 18? Well, our width is 14, and this looks a little bit longer than the width, right? So yeah, 18 is probably a pretty reasonable answer. And you could go ahead and check your answer and go backwards, work backwards, apply the formula in, and 2 times 18 times 5 plus 2 times 14 times 5 plus 2 times 14 by 18. And if you did all that and you come up with 824, then you know your answer is correct. So you can always go back, double check your work by plugging in what you solve for, plugging in the value that you got for that variable, and see if you would truly get back to the original surface area that you started with. The next one, surface area of a cylinder is 502.4 square centimeters. What is its height? And again, use 3.14 and round your answer to the nearest hundredth. So let's go with surface area of a cylinder. So we know that it is 2 times the area. So it's going to be 2 times pi r squared. That would give us 2 of those, right? The pi r squared is for the top, and then doubling it would take care of what we need for the bottom. And we're going to add that to, remember, circumference is going to be the top edge. This is like peeling off that label there. So we're going to have circumference is equal to 2 pi r, and then times the height. That would give us, this is going to be one edge. That's going to be that edge around the circumference there. And then we're going to have the height here. So with that said, let's go ahead and plug in those values or into our formula here. So we have our circumference, which is 2 pi r, and then times the height. Now, what is it that we're missing? We're missing height. So we're going to end up solving for h whenever we plug all this in. So our surface area is 502.4. I know it seems kind of strange putting something in it. We're so used to that, working that for the answer, that students will sometimes have a hard time realizing, wait a second, they're giving me what goes on one side and I'm missing something over on the other side. I need to solve for that something, in this case being the height. So we're going to start plugging in our values, and I guess we can go ahead and put it in parentheses. Why not? Let's go 2 times pi, and they want us to use 3.14. We're going to multiply that times the radius squared. Well, the radius is 5 squared. And then we're going to add to that the quantity of 2 times pi, and that's going to be 3.14. And then we're going to multiply that times the radius, which is 5. And all that's going to get multiplied times h. So let's take our next step here. It's going to bring down our 502.4. And 2 times, well, first let's take 5 and square it, and that's 25. And then we're going to multiply that times 2, and we're also going to multiply it times 3.14, and that's going to give us a product of 157. And now we're going to add that to 2 times, I can do this one without a calculator, 2 times 5 is 10, and 3.14 times 10 is going to move the decimal over one place, so that's going to be 31.4. I think whenever I did this the first time, I actually messed up on this, and I thought move the decimal over 2 places. So 3.14H, right? Now, let's go ahead and subtract 157 from each side. So 502.4 minus 157, and that's going to leave us with a difference of 345.4 on the left, and over here we still just have 31.4H. Now let's divide both sides by 31.4. That would leave us with just H on the right, and I still got that 345.4 on my calculator, so I'm just going to hit the divide by 31.4, and it's going to give me a value of 11. Yeah, whenever I did this last time, I was off one decimal place whenever I practiced for this, and I ended up with 1.1, and that's a really good example of does your answer make sense. So H equals 11, and from this picture that looks about right. It looks like it's about twice as tall as what the radius is up here. So the picture looks about right. But whenever I did this, I had 1.1 because I was off with that decimal place because I thought 2 times 5 is 100. I actually knew it was 10, but I moved the decimal place over 2 places instead of 1. So I ended up with 1.1, and sure enough, I went ahead and put that answer in, even though it didn't seem to make sense. So if you end up with an answer that doesn't quite look right, it doesn't make sense, feel free to go ahead and double check your math and make sure you got all that squared away. All right, surface area of a cone is 87.78 square inches. What is the slant height of the cone? And use 3.14 and round your answer to the nearest hundredth. So surface area of a cone. Surface area of a cone is equal to, it's pi times r times the quantity of s plus r. S plus r. And I'm going to look at my cheat sheet over there. Indeed, it is pi r s plus r. Yep, did it from memory. Double check. So let's see. And remember, s is going to be our slant, r is radius, and for pi, we're going to use 3.14. Okay, let's go ahead and plug in our values that we know. We know that 84.78 is the surface area. For pi, we're going to use 3.14. We're going to multiply that times the radius, which we get right here, which is 3. And then we're going to multiply that times the quantity of s plus r. And s is what we don't know. However, we do know that the radius is 3, so we'll put that in for the radius. So let's go ahead and start working this out. We're going to bring down the 84.78, and we're going to do the 3.14 and multiply that times 3 and get 9.42. 9.42. And then let's bring down our quantity of s plus 3. S plus 3. Now I'm going to distribute that 9.42 into the quantity of s plus 3. So 9.42 times s is going to be 9.42. And then I'm going to go ahead and distribute that 9.42 and multiply that by 3. So let's multiply that times 3, and that's going to give us 28.26. 28.26. Now let's go ahead and subtract 28, and I'm missing the s right there, aren't I? There we go. So I'm going to end up with just the 9.42s on the right. I'm subtracting 28.26 from each side. So 84.78 minus the 28.26 is going to give me 56.52. Now let's divide both sides by the 9.42. What we do to one side, we're going to do to the other. Those will cancel each other, leaving me with just s on the right, and 56.52. Going to divide that by 9.42, and that will give me an answer of 6. So our slant is 6. Does this seem to make sense that the slant right here is equal to 6? Yep, that would seem about right. Maybe twice as much as the radius. Seems pretty reasonable to me. Okay, for the next one, I did not come across a problem that gave you a triangular pyramid, or triangular prism, sorry, that gave you the length or the surface area and then gave you a missing value. So I figured I'd throw this in and make one up just in case you come across something like that. So in this case, they want to know what's the value of x, and I wrote this up as the height, right? And here, let's say they give us the surface area. I went ahead and put the correct answer for this one was 1664. You might recognize this as the problem that we did earlier where the answer was 1664. It's the only triangular prism question that I encountered whenever I did the activity. So let's go ahead and go with the surface area of 1664. And we know that this is equal to the area of the two triangles plus those panels. So with that said, we're going to go ahead and do the area of the triangles first. So let's do 2 for two triangles, one at the front and the back. And then let's do 1/2 times base times height. For 1/2, I'm going to use 0.5. 1/2 times the base, which is 24, times the height, which is what we don't know. We'll just call it x. So that is, right here we have one triangle, 1/2 times base times height, and there are two of them, so we're doubling it. Now we're going to add to that 2 times the 20 by 20 panels, right? So again, remember that we had these 20 by 20 panels here. We've got one here, right? That's 20 by 20. And then there's also the one that's over here on the back side that would also be 20 by 20. And 20 times 20 is the same as 20 squared. So we're going to go ahead and put in 20 squared for that. And then we're going to add that to that last panel. And that last panel there, let me grab we'll go blue, right? So the bottom would be 24 on one side and 20 on the other. So with that said, we would have a 20 by 24 panel. So that would be 20 times 24. Not really a formula for it. Again, we can't really develop a formula for it because it would be different for an equilateral triangle versus an isosceles triangle versus a scalene triangle. So we'll just have to go with what we see and plug in those values. Again, I didn't see a question like this. You may not run across it, so this is just kind of like bonus material, right? So let's go with 2, well, let's look at this. 2 times 0.5 would be, what, 1, right? 1/2 of 2 is 1. Then 1 times 24 would be 24. And then let's bring our variable x, which is the height that we're solving for. Add to that 20 squared should be 400. 400 times 2 is 800. And add to that 20 times 24. Well, let's double 24 and get 48 and throw a 0 on the end. 480, right? Why I didn't do that mental math the first time, I don't know. Got caught up in trusting the calculator a lot. So let's bring down the 1664 and bring down our 24x. Let's add our 800 and our 480. But that'd be 1280, right? Plus 1280. And now we're going to go ahead and subtract 1280 from each side, leave me with 24x and 1664. We're going to subtract from that 1280, and that's going to give us 384. 384. And then divide both sides by 24 would give us an x on the right, and 384 divided by 24, please give me the right answer. Indeed, it is 16. And I remember that that was the correct height for that particular problem. And that means that, and actually it want to be 16 square centimeters. It'd just be 16 centimeters. I forgot to scratch that one out. Square would mean area. We're just talking about linear length, so it's just 16 centimeters in this case. All right, it's been extensive, but those are all of the examples that I have for IXL Activity A1.F.5 Surface Area, and good luck with your activity.